How does the LSB affect digital to analog converter accuracy? Imagine trying to paint a picture with tiny color dots. The size of each dot determines how smooth and detailed your picture looks. In digital to analog conversion, the smallest step the converter can make is called the least significant bit, or LSB. It's like that tiny dot, setting the limit for how fine the output can be. The LSB is calculated by dividing the total voltage range the DAC can produce by the number of levels it has. For example, if the full-scale voltage is 1 volt and the DAC has 12 bits, it can produce 2 to the power of 12 levels, which is 4096. So, each LSB would be 1 volt divided by 4096, giving about 140 for microvolts. That tiny voltage step is what the DAC can change with each 1-bit increase in the digital input. This smallest step, the LSB, directly impacts how accurate the DAC output is. If the LSB is very small, the DAC can produce voltages that are very close to the ideal value. This means the output will look more like the perfect analog signal you want. But if the LSB is larger, the output can only jump in bigger steps, which makes it less precise. This causes what's called quantization error, where the actual output differs from the ideal voltage. The maximum error you can get from quantization is half of the LSB size. So, with our example of 240 for microvolts, the error could be up to about 120 to microvolts. Besides quantization error, other factors like nonlinearities in the DAC can cause the actual steps to be uneven. These errors can distort the output and make it less accurate. Engineers try to fix these issues with calibration and careful design, but the size of the LSB still sets the fundamental limit on resolution. In practical applications, like audio systems or precise measurement tools, having a small LSB is very important. It allows for smoother, more accurate signals that closely match the digital input. Larger LSBs mean coarser steps, which can cause noticeable inaccuracies or distortion in the output waveform. So, the LSB affects the accuracy of a digital to analog converter because it determines the smallest voltage change the device can produce. Smaller LSBs mean finer resolution and better accuracy. Larger LSBs lead to more quantization error and less precise outputs. While other errors can influence the overall performance, the size of the LSB is the main factor that defines how detailed and accurate the analog output can be.